Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Inshallah, today we will continue our lecture on research methods. But sebelum tu, saya just nak pastikan, okay, everyone is here. Alright. So today we will continue, kalau ikut our scheme of work, hari ini sepatutnya descriptive analysis should have been done last week. Tapi saya buat slight change. Last week kita buat research process, and then today we will do descriptive analysis, and then the following week kita akan cuba buat topik yang lain lah. Alright. So I feel that yang last week we should have started dengan research process tu, sebab I wanted to give you an overall picture of what is going to happen about your research. Okay. Saya ingatkan tadi tak nak buat kelas hari ni, sebabnya tengah hari tadi tiba-tiba my laptop kaput. Saya pun tak tahu what happened. Tak boleh nak on pula. And then nota ni pula dalam laptop tu. Nota yang ada dekat thumb drive tak save pula. So itulah dia. Tapi nasib baik berjaya pergi kedai and just dapatkan balik data tu, tapi laptop still kaput lah. So ni pakai tablet pula, so we'll see how lah. Kesian jugalah saya ni. Okay, tapi tak apa. We will see what we can be done. Alright, so today we will do descriptive analysis. Descriptive analysis ni is the most, one of the simplest form of analysis method. Normally, semua research you will have descriptive analysis. Okay. Is a very basic one lah. Descriptive analysis ni sangat basic. It does not tell you much. It just tells you the numbers, figures, itu sahaja. It just shows you that, but it does not tell you more than that. If you want to do more than descriptive analysis, then you have to start running a few tests. Tapi if you just want to show the number of people working in a certain location, the number of female, male, highest qualification, what else? Just facts sajalah. Okay, these are facts saja. Contohnya, let's say for example, you did a survey, and this survey you did with school kids. Okay, so descriptive analysis would be, maybe you can tell how many Malays, how many Chinese, how many Indians, what is their level of education, are they standard 4, standard 5, and then what else? Maybe they are how many boys, how many girls. Okay, they're very descriptive. It does not show you anything good. Okay, but you need to highlight descriptive analysis in your research to just show the exploratory of your findings only. Okay, you cannot. There's nothing much you can show of descriptive analysis. Okay, all right. So next, we need to understand in descriptive analysis, we need to understand a few terms or key concepts. One is we need to highlight what is descriptive itself. Okay, and from descriptive, we will move on to inferential. Okay, what is inferential? Okay, from then we also need to understand what is our variable, and then what is our data. Okay, so we need to understand what is our variable, what is our data. So with all of this, then we can proceed. We will understand more. So we start with descriptive, and then kita perlu faham juga what is inferential, and then daripada inferential, we need to understand what is variable and what is our data. Okay, data yang paling simple lah. What is the data you collect? Okay, what is the data you collect? The number of people who own Samsung, the number of people, what kind of handphones do they use, what kind of cars do they use. Those are those are data. It does not make sense, tetapi kalau you kumpulkan data ni banyak-banyak, it makes sense lah. Tapi kalau setakat you just get seorang ada Samsung, seorang ada Huawei, seorang ada Lenovo, seorang ada all those other things, it does not make sense. Tapi daripada data itu, you can make kumpulan data, you can make something out of it. Alright. So what is descriptive research itself? Descriptive research is a study in which information is collected without changing the environment. You don't change the environment, you just ambil as it is. Okay, you take the environment, you just collect the data as it is. Budak pergi sekolah, okay, the number of kids who go to school, you just take it as it is. You do not change anything, you do not do anything with it. It is used to obtain information concerning the current status of of the phenomenon to describe what exists with respect to the variables or condition in a situation. Okay, so what does this mean is you just want to find out what is going on, what is the information there. For example, macam minggu lepas I have explained to you about exercise and losing weight. Okay, so we have exercise and losing weight. So the correlation is the more you exercise, the more you lose weight. So these are two variables. Exercise itu satu variable, and exercise itu satu variable, and losing weight itu satu variable. Okay, these are two variables. Okay, in descriptive analysis, we just find out who exercises or the number of time you exercise. Okay, ada orang cakap saya exercise 5 kali. Okay, and then we tanya, how much have you lost weight? So we have the numbers only. So these numbers does not mean anything. Okay, setakat number is just descriptive. Okay, that is what it means by descriptive analysis. Okay, next we move on to the actual meaning of descriptive analysis. Descriptive analysis describes the phenomenon that how we think something is, attempts to examine the situation in order to describe them. You just want to describe how many people exercise, what is their age group, do they own a big bike, small bike, are they from rural area, are they from urban area. Itu sahaja, you just want to describe that. Okay, describe what exists and tries to pave the ground for the finding for new facts. That means you pave the ground means macam ini menjadi basis lah. Okay, this become basis. So you're saying that exercise and losing weight, you need dua variable. Okay, so you want to know what is the significance of exercising and losing weight. Okay, so your descriptive analysis will be how many times in a week do you exercise, and in the last 4 months, what was your weight loss. These are only numbers. Okay, so these numbers akan menjadi, so from this, let's say ada 10 orang yang kata mereka cycle 2 kali seminggu. Okay, and ada lagi 10 orang yang kata dalam masa 3 bulan they have lost about 4-5 kilos. So this is your ground. So you want to see, now you have these two data, macam mana boleh samakan data ini? Adakah there is something going on? If I cycle more, do I lose weight? Or there is tak ada kaitan. Maybe there is something else besides that. Okay. It includes gathering data of related to products, okay, people, individuals, event, situation, and then organize, tabulate, depict, and describe the outcome. Okay, so product pun boleh. You can gather data about product. You want to know types of mobile phone in Perak. So you just want to know who owns what. Okay, ada orang kata I own Huawei, ada orang kata saya own Apple, ada orang kata Samsung. So you just collect this data. And then from this data, you make a finding and you kata, in Perak, a lot of people own Samsung because out of 100 people we interviewed, we collected the data from, 45 people own Samsung, 10 people own Lenovo, and so on and so forth. So it just describes. Okay, so you can also get your data from product. Next, to investigate the background of a research problem and get required information needed to carry out further research. Okay, so descriptive analysis is for you to get information to proceed further. Okay, it is used in multiple ways by different organizations as well as when getting, especially when getting the required information about target audience. Okay, so organizations use this. Maybe they use this descriptive analysis for certain condition. Let's say in a company, the human resource finds out that there are, let's say dalam UiTM lah, dia buat survey and dapati bahawa kebanyakan staff dalam UiTM birthday mereka ialah pada bulan 11. Okay, So now they know. So maybe they can say, okay, now there's a orang nak buat birthday celebration ramai-ramai ke. So using those kind of data. Okay, so organization will do so many things. Okay, mungkin organization dia nak compare how many males and females, so dia buat survey. Okay, itu saja. They want to get from this data, they want to manipulate and to get something. They do not want to say this data is related to that data. No, they just want to know how many of this and how many of that. How many people are there in this company who are from macam sekarang ni PKPB dan PKPD dalam Meru kan, Meru Dosi. So kalau you buat a descriptive research, a descriptive survey, you can find out how many UiTM staff are from Meru Dosi. Itu saja. Okay, you find out katakan ada 50 orang. Okay, so that is your finding. Okay. Any questions so far? Semua okay di sana ke? Semua dah tergolek ke? Belum? Macam Mimi, are you okay? Haris, are you okay?
Okay, Doktor.
Okay.
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 Semua orang dah makan ke?
Sudah.
Sudah.
Alright, alhamdulillah. Okay, bagus.
Alhamdulillah.
Okay. Kenapa semua muka sedih saja? Muka tak nampak lah. Kenapa semua suara sedih je? Awak kena ceria. Kena ceria sikit. Okay. Alright. Main objective. Okay. Main objective of descriptive research is, ini yang saya highlight, does not make predictions and does not determine cause and effect. No. It does not make any prediction. Okay. No cause and effect. Cause and effect, macam tadi lah saya kata, exercise and losing weight. You just get data and you are not going to say nothing. That's not the problem. You don't do any tests. Okay. You don't do any tests. So there's no effect. You just get the number of people who exercises and the number of weight loss. Itu saja. You don't make any cause and effect. Cause and effect ialah what causes this or what affects this. Okay? What affects this, what causes this. Alright. So it is often done before an experiment, exploratory, inferential research to know what specific things to manipulate and include in the experiment. Okay? So before you do your study, you do this descriptive work. You not find out certain things so that you can test. You can do inferential more. Okay, so now you know the number of Samsung users in Perak is banyak ni. Okay, the number of Apple users in Perak banyak ni. Okay, so now you have this figure. From this figure, you can infer. Infer meaning infer means you are playing with the data. So you put something in the data. Let's say you find out in your descriptive analysis the number of Samsung users in Sri Iskandar is 100 dalam satu taman. So now you can infer by saying probably jika saya buka satu kedai Samsung, it might be good because a lot of people here uses Samsung. That's what I mean. Yeah. Okay, it could be lah. Or you see the number of students staying in that area, that particular area, Sri Iskandar Bandar-Juru semua. The number of students staying outside in around the area is about 1,000 plus. Okay, so now you infer, you kata that is descriptive. Descriptive, you jumpa ada 1,000 orang pelajar di situ. So now you infer, you kata maybe possibility of opening up a fast food restaurant will be good because the more fast food restaurant, the higher students, the better fast food restaurant is. Okay, so you try to infer with this data. What can you infer? Okay, with this data you want to infer more, but you cannot say any cause and effect belum lagi. But based on this, you have an idea. So you explore more and then you test on that.
Betul, yang descriptive ni maksudnya dia kalau kita buat dalam questionnaire tu dia demographic kan? Demographic.
Yes, area. This is where demographic comes in. A lot of descriptive data comes from demographic. Age, education, gender,
position.
salary. Sorry, apa dia?
Position.
Position. So katakan you buat survey 100 people and you dapati bahawa 20 managers, 30 orang daripada kawasan luar bandar. Itulah. So that gives you an idea lah Okay, 30 orang. So kenapa, one more interesting point Encik Azrul, bagus ni. Because based on this, you boleh infer balik in your conclusion. In your conclusion, you boleh kata, kenapa result yang you jumpa ni setelah you buat your PhD and all the thing, kenapa result you macam ni? Sebab, going back to my survey, a lot of my respondents ialah orang-orang luar bandar. So, orang-orang luar bandar, macam inilah keadaan dia. So, that's why it could be like this. Or maybe you can say, this test can be also replicated to kawasan bandar and the result might be different. Because of your descriptive ni, you dapati bahawa ramai yang menjawab ni ialah golongan luar bandar and B40 ke apa namanya, whatever. But you keep that. And then bila you infer balik dekat conclusion tu, you rasa this data ni yang you jumpa berapa ramai ni can also describe your it can also help you to analyze. So you kata it could be kalau kita buat study ini di bandar, it could be different. But di luar bandar, because of my ni, it is different. Okay, so you can play around descriptive ni. Descriptive ni is just to collect data je.
Okay.
Example, how students spend their time during year-end holiday? Description of, ini of. Of the smoking habits among teenagers. Description of how parents feel about 2020 2020 school year. Ini memang semua orang sebagai seorang mak ayah, I think all of you can answer this lah. Do teachers hold favorable attitudes towards using computer in school? Okay, so these are certain descriptive research. Okay, descriptive research. Okay, descriptive. So from this you will find out lah, you will cari all the data. Macam for example, kita ambil soalan 1, 2, 3, 4. Question number 4. Do teachers hold favorable attitude towards using computers in school? Okay, so ambil Cik Azrul punya point, demographic. Cikgu, okay, cikgu ni berapa lama dia jadi cikgu? How many years have you become a teacher? Bagi julat. Okay, bagi julat. And then maybe you can say, is this your first posting? So kalau cikgu baru grad lah, okay. Lepas tu maybe you can ask maybe you can ask also, do you have any experience using software? If yes, namakan software apa? Okay. So based on those data, you buat descriptive analysis. You kata number of teachers yang you interview ialah 100. 50% out of it are new teachers, and another 40% is retiring teachers, and most of them do not have computer experience sebab tak ada siapa yang tahu software. So these are descriptive saja. Okay, you're not making any conclusion yet. You belum jawab lagi soalan favorable tu. You just cakap inilah dia demographic saya. Alright. Okay. Important key points about descriptive research. It focuses on answering the how, what, when, where questions rather than why. Why tu belum lagi. Why tu belum. Okay, why is your research? Dalam descriptive, we are not talking about this. Okay, why do teacher feel favorable? Tak, kita tak menjawab soalan tu. Itu dalam cerita lain. Dalam descriptive ni, we only write how, what, when, where. And it investigates phenomenon in their natural setting. That means you look as it is. You are looking at as it is. That means you are not doing anything. You just bagi survey and you collect the data as it is. Cikgu pergi sekolah, balik sekolah, you're not doing anything. Okay, you collect the data as it is. Deals with the present. Okay, that means what is the current situation. But in that means you are asking questions yang at that point of time. Pada masa ini. Pada masa 2020, what is the problem? What are you doing? But in latest books that I have read, we can also tell our respondents untuk descriptive, in the last 5 years, what kind of technology have you been using in so and so. We can also ask the respondents untuk balik 5 years ke belakang and give your answer based on 5 tahun ke belakang pun boleh dah sekarang. Okay, but kebanyakan descriptive will look at what are you doing now. What is during your ODL session with your students, what software are you using? Bukannya have you been using, are you using? Oh, sekarang ni saya guna let's say you bought Google Meet and you on WebEx and all those things. Okay, now manipulation of variable is not possible, so you cannot manipulate. Dalam descriptive, we are not talking about any manipulation. That means we are not manipulating between exercise and losing weight. Okay, kita cuma ada dalam kepala kita, this is something, but we are not manipulating anything. Manipulating maksud saya di sini ialah, what does manipulating mean? Manipulating means you do certain tests. You buatlah correlation test ke, Pearson test ke, all those chi-square lah, t-test lah, no. Those are manipulating. You dah manipulate dengan your data, but in descriptive, you don't manipulate. Okay, next we look at inferential. Okay, inferential. Sebelum saya masuk kepada slide number 9 ni, I want to show you a picture and then kita balik kepada inferential. Inferential ialah macam ni. Okay, this is the picture of inferential. Mungkin daripada ini you will understand a bit more. So descriptive statistics used to describe, organize, summarize information about the entire population. Okay, 90% satisfaction of all customers. Inferential pula used to generalize about a population based on that sample. 90% satisfaction of the sample of 50 customers equals to 90% satisfaction of all customers. Macam ni. So what does that mean? Let's say population dekat Seri Iskandar daripada Terengganu sampai ke UiTM, population ialah let's say dalam katakanlah 10,000, maybe 30,000 lah. That's your population. Daripada population ini, for your research, you nak ambil satu sample of B40 group. Okay, so B40 group. So you take the sample of B40 group. Okay, so the sample of B40 group, let's say dalam 1,000. Okay, and then, so 1,000 now becomes your descriptive. Okay, so you do your descriptive analysis daripada situ, and now, bila you dah habis descriptive analysis, you nak buat inferential statistics, hasil daripada the results from inferential statistics can now be it can now be representing yang population tadi. Okay, meaning to say, hasil daripada kajian yang 1,000 orang ini kita boleh generalizekan balik the 30,000 yang dalam population tadi tu. Okay, so kita ambil 10,000, based on this 1,000, it can reflect balik. Kita boleh reflect balik the general population. So that's why kalau you tengok dalam kotak inferential ni, 90% satisfaction of the sample daripada 50 orang customer, 90% is satisfied. Okay, so bila satisfied, 90% satisfied, okay, your research can say, maka semua orang satisfied. Semua orang satisfied kat situ. Okay, so kalau ada orang tanya soalan je. Okay, so dalam UiTM, let's say Seri Iskandar about, okay lah, saya tak ingat Seri Iskandar ada berapa ramai, Tapah ada 300 orang staff. Okay, so saya ambil 50%. 50% is 150. Daripada 150 ini, I do a happiness index survey, I find out that 80% are happy. Okay, 80% are happy. So based on this 80%, saya boleh mengatakan bahawa I'm confident enough to say 80% out of the whole population in Tapah is happy. Walaupun my survey tadi hanyalah 150 orang. But I can generalizekan balik kepada semua. Okay, so inferential statistics or analysis means you infer balik pada population awak semua. Okay, are you all okay di sana?
Okay.
Okay, Doktor.
Jadi dari segi percentage tu, contohnya 90% kita generalizekan kepada all customers certified lah dengan service kan.
Yep.
Tapi apa nama dia panggil, dekat point mana yang kita nak katakan contohnya 60% and below yang tak, kalau result yang kita dapat 60% and below, maksudnya dia tidak certified, ataupun macam mana kita nak tentukan point tu di mana?
Okay, good question. Alright, nanti dalam slide bawah-bawah ni ada satu point yang nama dia sample size. So based on that sample size, we can say kalau sampel kita setakat 100 orang and our population is 1000 orang, you cannot generalize lah. Okay, even kalau you kata population you 1000 orang, you ambil 100 saja, and 100 ni kata 100% mereka setuju dengan awak, you cannot say yang 900 orang ni akan bersetuju dengan awak. Tidak boleh macam tu. Okay, so betul lah Zul, ada point dia yang mengatakan bahawa there is a number of sample size tu yang you can, dia bukannya point macam 60% ke apa, dia based on sample size awak. Sample size. So katakan population 1000, awak samplekan 100, and daripada 100 90% satisfied. So you kata okay, so 90% daripada 1000 orang satisfied. That does not make sense lah. That does not make sense. So betul, dia ada sample size tu yang nanti kita akan tengok dalam I think slide bawah ni akan ada sample size. So based on that sample size, then only you can generalize balik ke atas.
Doktor, saya nak tanya, yang tu kalau dari segi population kan, what if kalau macam expert, macam expertise kan dia tak ramai. So contoh kita macam ada maksimum dalam 8 orang expertise dalam that area tu. So bolehkah kita gunakan dia punya data ataupun dia punya dia punya jawapan tu ataupun interview ataupun statement yang dia cakap tu sebagai inferential punya data juga?
Yes, you can. If those are experts are recognized by someone, maka dia experts lah. I mean, that is your population lah.
So maksudnya dia tak perlulah sampai 100 plus pun kan? Even 5 orang expert tu pun dah memadai. Is it something like that?
Yeah. The 5 experts are experts. 5 experts are experts lah. Sewaktu in 1980, in 1980-an semua, bila kita baca journal mengatakan bahawa you cannot have, your experts tak boleh lah sampai 5 orang, 6 orang, 7 orang. Okay? Tetapi bila sampai tahun 2000 onwards, mereka mengatakan bahawa buku ni, research method lah, saya dah baca waktu buku ni, buku mengatakan bahawa dah boleh dah. Maksudnya you dah boleh, even kalau seorang atau 2 orang itu expert, itu dah dikira population you. Sebab dia orang mengambil contoh study on orang-orang gila. Okay, orang gila. Orang gila di Tanjung Rambutan, setiap orang gila itu berbeza. Bermaksud, even kalau you study seorang, you cannot generalize dia dengan orang gila sebelah dia. Tak boleh. Setiap orang gila itu berbeza. Walaupun dia punya ciri-ciri dia sama, tetapi each individual mentally disabled mental disabled tu is different. So again, berdasarkan itu, based on that, experts are experts. However, you need to prove, or somebody needs to prove they are experts. Maybe you can do ciri-ciri lah. Determine expert ni ialah pengalaman 10 tahun and so on and so forth. Dia adalah ciri-ciri dia, so that orang tak adalah question you.
So maksudnya dia akan jadi macam purposive sampling ke?
Exactly.
Alright, thank you.
Tapi you must make sure lah yang purposive sampling itu based on kriteria lah. Let's say dia ada 20 tahun experience, dia dah buat 10 project and he has bank balance yang banyak ke, dia ada ciri-ciri dia untuk mengatakan that is an expert.
Maksud doktor dia kena ada standard guidelines untuk that purposive sampling ke?
You start the standard guidelines.
I understand. Thank you.
Satu lagi Azrul, lupa nak cakap tadi. Sample size tadi, beberapa buku ada macam-macam cara determine sample size lah. Ada yang cakap berdasarkan soalan. Contohnya kalau you ada 10 soalan, tolak demografik punya soalan, you ada 10 soalan, satu soalan kita perlukan dalam 10 orang. Itu hair yang statistician tu dia kata satu soalan 10 responden. So kalau 10 soalan 100 lah kot macam tu. Ada yang kata it should be based on the population, dia ada calculation dia lah, berdasarkan population, berdasarkan ni semua lah. Tetapi rata-rata bila saya tengok jumlah survey tu, dia tak ada standard personally maybe you can check this over juga. Dia tak ada standard yang kata you need to have about your respondent rate dia should be, ataupun jumlah survey yang boleh pakai hendaklah this number, X number, tak. Masa saya buat PhD, when I did my survey, memanglah soalan saya dalam I think about 30 soalan, dan 30 soalan sepatutnya saya cari 300, tetapi setelah saya tolak-tolak memang tak cuma 300, I think I did only about 110, 110 orang sahaja. Saya punya ialah macam Syamimi kata, pakar dalam project management IT. So I found pakar yang dalam project management IT lah. So I found in total 110. So the number of sample size ni is very tricky. So saya nak jawab sekarang pun payah juga. So ada study yang kata satu soalan 10 orang, satu soalan 5 orang. So maybe kita kena baca on that area balik.
Okay. Dia maksudnya macam apa, daripada population kita tentukan berapa sample size kita. So ada yang mengatakan contohnya 30% daripada sample size respon, maksudnya kita dah cukup lah, boleh proceed dengan analisis. Maksudnya tak perlu tunggu lagi.
Betul. So saya ada satu bahagian dalam my masa saya submit thesis, masa dapat correction tu, my examiner tanya saya 110 saja, macam ada tak puas hati sikit lah, macam cukup ke kan. So I had to do a sub-chapter dalam sebelum conclusion, bercerita pasal sample size. So saya terpaksa baca balik beberapa jurnal yang akhirnya saya kata there is no standard number yang mengatakan bahawa this is good. Tak ada siapa yang cakap macam tu. Cuma semua orang cakap you dapat 100 bagus, you dapat 20 macam ada macam-macam lah dia punya idea tu. Ada cakap macam ni, ada cakap macam tu. So that was what I did lah. So okay lah, kira lepas tu dia tak jawab balik, so kira lepas tu Okay, let's just go back Okay, so this one okay, terpatah balik. Alright, inferential. Okay, ini tadi kita dah tahu inferential tu apa. So this we just go back and see what does it mean. Is deeper and attempts to explain why. Okay, so tadi tak ada why, now dah ada why dah. Okay, so now we are going deeper dah. Okay, provides us with information to understand the very nature of linking factors of phenomenon and predict the future behavior. So now we are looking at linking the factors and predicting the behavior. Exercise and losing weight. So we want to predict the behavior. So am I going to, the more I exercise, the more I lose weight ke, macam mana ke? So we are now trying to predict that. Okay, this is what we say is inferential research. Takes data from sample and makes inferences about the larger population. Macam tadi soalan Azrul tadi. Ambil sampel daripada population. Population you 1000, ambil sampel. Okay. And from that sample, you want to find out something. And from that hasil, the result pada sampel itu, you nak generalisekan balik kepada population tadi tu. Untuk reflect. That's why we see. That's why point nombor 2 ni, dekat paragraph point nombor 2, the bahagian last tu, we need to have confidence that our sample accurately reflects the population. Okay, accurately reflects balik kepada population. Okay, beberapa example. We measure the heart rate of each student in Mrs. Green's class, and the mean was berapa beats per minute, the standard deviation was berapa, the minimum was berapa, and maximum was berapa. So dalam research ni, dia orang masuk satu kelas and they orang measure heartbeat setiap pelajar dalam kelas 1182, and then from that they found out that mean tu berapa, standard deviation tu berapa, minimum heart rate tu apa, and maximum heart rate tu apa. Itu saja. Okay, that is descriptive. Bila you buat inferential statistics, we measure the heart rate of each student in Mrs. Green's class, 118, and announce that we are 95% confident that the mean heart rate of the students who walk regularly is between X and between apa dan apa. So based on that, kat sini you nampak kat inferential statistics ni, you look at the word 95% confident. I mean, they are saying that mungkin cikgu ni seorang yang garang, so budak-budak dalam tu is very takut, so they want to prove this. So by using, how to prove this, they're using heart rate. Okay, so this is one chart of inferential statistics. Okay, okay, now we go back to population tadi. Consists of all items and elements of interest of a particular decision investigation. All merit staff over the age of 30 in UiTM Perak. Okay, this is our population. Okay, sample, certain number of elements that have been chosen from the population. So population tadi ialah semua. Okay, population sample kita ialah hanya staff FSPU. Okay, so katakan di Seri Iskandar ada dalam 500 orang, takkan 500 kan, okay lah, sajalah ambil 500 lah. Okay, 500 orang staff yang berumur 30 ke atas yang dah berkahwin. Okay, that's population. So sampelnya ialah kita ambil hanya daripada FSPU. Okay. Alright. Okay. So this is one type of sample lah. Okay. Ada soalan lain? Ada soalan? Okay. Alright. Masih hidup di sana?
Ada.
Ada.
Awak semua ni buat lah macam lawak-lawak macam havoc ke, buat bising kat kelas ke. Okey lah, saya cerita lawak saya pada hari ini. Today I was doing a class to my diploma students. Selama saya kira, I think about 5 to 8 minutes lah tentang teori tangan macam ni. Then saya kata satu ayat, okay, now you look at point number 2. Point number 2 explains about this. Ada suatu suara daripada slide. Sir, tak ada slide pun.
Tak nampak.
Rupanya dia orang tengok muka saya je. So itulah dia. Lain kali sebelum tu saya akan tanya, dah awak dengar. So, before this pernah terjadi, I was talking alone for I think 10 minutes.
Oh.
Diorang pun tak cakap.
Itu biasalah.
When you do online class, dia ada dua possibility. So ada orang tak dengar and diorang tak tengok slide lah kan. Macam tadi saya dah kena dua-dua. Dulu masa kita pergi kelas tu, kelas kita back to back. So kadang-kadang terlepas. So you masuk kelas ni, you ajar subjek lain. You ajar benda lain and then diorang pun sebab takut dengan you, diorang pun dengar jugalah. Itu pun pernah terjadi jugalah. Okay. Alright, so I think I woke you up already. Okay. Okay lah. Boleh tak kita just stop 8:43, we stop for about 5 minutes. Kita mula balik 8:50. Kita pergi minum air sekejap, boleh?
Boleh.
8:50 ya, 8:50.
Baik. Okay.
Okay, all right, let's continue. Okay, Puan Syamimi ada di situ, Azrul?
Ada.
Ya, tak lari ya. Okay, so just ulang balik, population, the number of staff, okay, all merit staff over the age of 30 in UiTM, and then sampelnya ialah kita ambil satu bahagian, kita ambil FSPU saja, so that's our sample. So based on our finding, we can do maybe we can do inferential balik pada population tadi lah. Okay, so that's what sample and population is about. Okay, next we are also looking at the types of data. Okay, ada beberapa jenis data yang you can manipulate in your descriptive analysis. You can manipulate nominal, ordinal, and ratio data. So nominal is made up of categorical data. Category data ni is based on, contohnya, how often do you study research methods? Daily, weekly, monthly. Okay, dia ada it's either daily or weekly or monthly. Those are dia ada kategori lah. Okay. Ordinal ranking reflects ranking in order of importance. What grade did you score in the research method subject A, B, C? So that is your ranking. Okay, so you bagi rank lah. Okay, macam saya bagi you 5 step untuk, let's say 5 steps in repairing your bicycle. So you do the ranking. 1, 2, 3, 4, 5. So that is ranking. Ratio is made up of numerical data. What marks did you score in your first assignment? The numbers. Okay, when we talk about ratio, we talk about numbers. So it's only a fixed number. Okay. Let's say we are looking at the weight, okay, berat badan of 100 people or 100 students. So ada yang 70, ada yang 80, ada 50, those are numbers. So that is a ratio lah, the ratio data. Descriptive survey yang ni you boleh baca lah, these are only text saja, tak ada benda sahaja. And the nature ini pun tak apa, it's nothing much lah. Okay, alright. Now, variable. So tadi we have talked about data, so we tolak tepi. Now we are talking about variable pula. Okay, so variable macam tadi I gave you early in the class, we talked about losing weight and exercising. So those are two variables. So any factor that can have an effect in an experiment. Experiment di sini, perkataan eksperimen kat sini, it does not mean eksperimen macam sains gunaan, bukan eksperimen itu. Experiment means what we are looking at, apa yang kita tengah kaji. Or experiment is our research lah. Okay, so what are the factors? What are the variables? What are the factors? What is the factor that can have effect on that? On losing weight, so what are our factors? We have exercising, kita ada puasa, kita ada fasting, and so on. So those are some of the variables. And then we also have independent and dependent variable. Independent is a variable what is being changed on purpose. That is independent by itself. Dependent is what is being tested or measured. So we are looking at losing weight. So we want to find out which of these variables contribute most to losing weight. So losing weight itu ialah a dependent variable kerana losing weight itu bergantung kepada our independent variable, iaitu exercising, puasa, dan lain-lain lah. Okay, so that is our independent variable. Independent variable ini boleh berubah. It can go high or low. The more you exercise, the more you fast, the more you eat well. Okay, and it will affect dekat losing weight tadi. Okay, so independent variable can change. Change, what do I mean by change? Change in the value lah. The more, less. Okay, lagi banyak, lagi kurang. The more you exercise, the more you eat, the more you fast, contributes more to your to your losing weight. Okay, and then we also have a control variable. These things are the things that you keep the same and do not change during the experiment. Okay, so control variables are variables that remain the same, meaning you are keeping those variables. Example of variable is you are keeping, let's say, exercising and losing weight. So a control variable meaning you are looking at only gender, female. So you control that, or you're controlling the age factor. So you keep at the age of 30. Everyone is kept at the age of 30. Okay, you're looking at only those who are 30 and above. So you control that variable. Okay, or you control the age. Okay, you're only looking at this particular age, or you control the gender, female, male. Okay, so you control this. So you don't worry about other stuff. So even kalau you dapat your study, you are looking only at those people yang puasa 7 hari, or those people yang 30 tahun ke atas. So you control these variables. Okay. Furthermore, what is dependent variable? Dependent variable ini secara statistik variables which value you wish to predict or summarize. Dependent variable. Okay. So losing weight is what we say as a dependent variable. You wish to predict this. You want to know how much can you lose weight. Also called responses or outcome of the variable. So that's why it's an outcome lah, apa yang boleh terjadi. And kalau you lukis graf ini, dia dalam bentuk it's on the y-axis yang menegak lah. Okay, independent. Secara keseorangan, the variables on which dependent variables depend. Dia bergantung kepada independent ini. Also known as exploratory, predictive, or risk variables. Exercise, fasting, eating less. So these are independent variables that cause losing weight. Okay, so I repeat myself. Exercise, eating well, fasting. So these are independent variables which cause an effect of losing weight. Okay, so independent variable ini berada di in the X. A variable in research simply refers to a person, place, thing, phenomenon that you are trying to measure in some way. Example of dependent variable is depression. Okay, and which depends on independent variable, maybe therapy. Okay, so mungkin we can say the higher therapy, the less people will go through depression. Okay, mungkin macam itulah. So depression is the outcome. So how to overcome this outcome is maybe dikata through therapy. But berapa banyak therapy is we say, maybe we can say higher therapy, lower depression. Maksudnya, if someone goes for a lot of therapy, maka his or her depression can come down. So we control this by saying we are only looking at students. So this is our control variable. In an experiment, the researcher is also looking for possible effect on the dependent variable that might be caused by the changing of independent variable. Macam tadi lah saya kata. So what is the change? Apakah perubahan kat sini? Naik, turun, turun, naik. So we are looking at this. So dia independent naik, dependent pun naik, ataupun independent turun, dependent pun turun, ataupun dia berkadar songsang. Okay, the independent goes up, the dependent comes down, or the independent goes down and the dependent goes up. So we need to find out what is happening. Okay, classification of variables. So we have two kinds of this, categorical and numerical. So dalam characteristic are merely categorical. Unit of measurement is non-numeric ya. Kenapa dikatakan categorical itu sebagai non-numeric? Sebab you can take in data, contohnya colors. What color do you like? Types of colors. Red, green, blue. Dia tak ada number kat situ. What car do you own? Proton, Mitsubishi, Honda, no numbers. Your blood type, A, B, C positive, B positive. So, these are categorical. Numerical, characteristics that are measurable, boleh diukur. Bila saya kata boleh diukur, you boleh dapat ada number kat situ. Either discrete or continuous. Discrete meaning berturutan continuous maksud dia berurutan, atau discrete, it can vary. Ada seorang kata 10, ada seorang kata 20, 30, it can vary. And then you can have interval. Interval dia ada interval meaning kita bagi julat interval, or kita bagi ratio. Ratio is just a number lah. Okay. So obviously dalam statistik, the more numbers you have, the better. That's why line ada kat sini, the more informative. Okay, the more informative. Sebab sekarang ni kita bercakap about statistics. So statistics is more of numbers. So the more numbers you have, the better informative you can get. Okay. We also go, okay, what is independent variable? Inilah beberapa contoh kat sini. Independent variable, height of the plant, amount of fertilizer, amount of water, semua lah. Ada di antara awak yang ada anak dalam darjah 3 ke 4 ke? Siapa ada anak darjah 3, darjah 4? Ada? Tak ada? Okay, if you have any school kids darjah 3, darjah 4, make sure you know this. So dalam sains ada cerita pasal dependent ni tau. Ada cerita pasal independent variable ni. Sains ke matematik? Anak saya ada belajar masa darjah 4.
Betul. Kiranya term dia pakai term macam ni ke yang darjah 3 tu?
Dia pakai dalam bahasa Melayu. Dia pakai dalam ni. Kalau ambil DLP dia pakai ni lah.
Ya kan, anak saya darjah 2.
Sikit lagi atau sikit lagi.
Okay.
So mak kena tahu dah benda ni.
Okay.
Sebab dia pernah there was a question once which I also cannot answer. Tuala dengan air. Okay. So dia nak tengok what is the inferential between bukan inferential, apa namanya, tuala dengan air. Maksud dia lagi besar tuala, dia boleh lagi menyerap ke, macam tu. So that was the variable. The variable is the tuala and the air. So dia nak tahu lagi mana yang dependent, mana yang independent, mana yang dependent. So you have to say lagi besar tuala itu, lagi banyak air boleh serap or something like that. So benda ni ada dalam darjah 4.
Okay.
Kita ni besar-besar baru belajar lah.
Betul lah.
So siapa-siapa yang belum sampai anak darjah 4, make sure you belajarlah benda ni, insyaAllah. Nanti boleh tunjuk terror kat depan anak. Okay, let's move on. Okay. Now, daripada slide nombor 22 hingga another 20 slides is going to be, we are going to talk about numerical data dulu, and then saya akan berpindah kepada categorical data. So daripada slide 22 onwards ni, saya akan cerita about numerical terlebih dahulu dalam 10-15 slide, and then saya akan pindah kepada categorical data. Alright, so in numerical data, we are looking at ratio. Macam I explained tadi, ratio is numbers. So how do we measure this? Okay, so before that, what is this slide about? This slide is telling you about numerical data. You have numbers, nombor dah ada. So, bila nombor dah ada, apa yang you perlu kaji? Okay, so don't worry. Bila you start your research, bila sampai analysis, you will have to think. Sekarang numbers dah ada. Nah, apa yang saya nak buat? Okay, so that's why your research methodology must be strong enough so that bila you collect data, dah habis collect data, you know what test to nak buat. Apa yang you nak kaji sebenarnya. Okay, so in descriptive analysis, statistical analysis, you are looking at numbers. You ada nombor. So daripada nombor itu, dia ada dua measurement yang kita boleh buat. Satu is what we say is the central tendency. Central tendency, we are only looking at mean, mode, median. Ini quite easy lah. Saya rasa ini semua orang boleh dapat. Or we want to find out the dispersion. Dispersion meaning how dispersed is our data. Okay, how dispersed is our data. Balik kepada cerita 1,000 orang daripada Tronoh ke Sri Iskandar. Okay, so in descriptive analysis dalam dispersion, we can find out daripada Tronoh ke Sri Iskandar, we can find out berapa ramai yang duduk Taman Maju, berapa ramai yang duduk di Lakeville, berapa ramai yang duduk di kampung XYZ. So we want to find out what is the disbursement. Okay, we want to show that your data is dispersed, bukannya hanya fokus kepada Lakeville. Okay, tak boleh ke? Boleh. You can only, let's say, convenience. You convenient dekat taman you sebab you ketua kampung, so you ambil lah kawan-kawan you kat situ. But in research, we want to show that our data is dispersed. We have got a good sample. 10 orang daripada Trono, 10 orang daripada kampung XYZ, 10 orang daripada Taman Maju, 10 orang daripada Lakeville, 10 orang daripada semualah. So it's a dispersed. So that's why we do a dispersed study to find the spread. Okay, and how do we do this? Is we do standard deviation, we do variance, we check the mean, we check the maximum, and we do interquartile range. Okay, itu yang I will tell you. Okay, so we are looking at the numerical data terlebih dahulu. Dan bila dah habis dalam 10 slide, baru kita bergerak pada categorical data. Okay, central tendency are numbers that tend to cluster around the middle. Okay, so ini senanglah. So look at the diagram. Earnings for the past week. Monday, they got 350. Tuesday, 150. Wednesday, 100. Thursday, 350. And Friday, 50. So based on this, our mean is this, our median is this, and our middle value is this. Straightforward. Very simple. Okay. Now, yang ni pula. Dispersion is how the data is spread out or dispersed from the mean. So daripada mean itu, what is, we are looking at the mean, start daripada mean, and daripada mean itu, what is the disbursement? The smallest disbursement, the more the smaller the dispersion value, the more consistent data. Okay. The larger the disbursement value, the more spread out data. This means data is not consistent. Okay. I think we will go into this. Okay. Okay. So we will go into this. What is the value of this? What is the meaning of this? Okay. So untuk buat disbursement ini, we have a few techniques. Kita boleh pakai range technique, kita boleh pakai interquartile range, kita boleh pakai variance, kita boleh pakai standard deviation. Kesemua ini, all of these techniques measure this. Boleh mengukur disbursement. So, question before you tanya, perlu tak saya buat semua ni? Tak perlu pun. You either can choose one of each. Tak masalah. Okay. You have to do semua ke? No, it doesn't matter. You can choose one of each bergantung pada your research. Tapi macam mana saya nak tahu mana satu nak guna? Bila you tak tahu mana satu nak guna, normally apa yang saya cadangkan ialah you baca your research on that area, or maybe you akan tahu, or kalau you tak tahu, normally people akan ambil range dengan variance. Okay, range dengan variance. Okay, sebabnya interquartile variance or standard deviation ni, interquartile ni biasanya companies will use it for a different purpose. Tapi untuk research, normally saya tengok range and variance is good enough. This is only to show there is disbursement in your data. Okay, kalau let's say you get a negative displacement, contohnya macam ni. Setelah you buat displacement, you dapat data is inconsistent. So, question, adakah benda ini salah? Tak, benda ini tidak salah. Okay, you dah dapat data, you dah ada data you, tetapi data you tak consistent. So, can the evaluator say, tak boleh pakai, because data not consistent? No, cannot. So, when you see, when you find out that your data is inconsistent, meaning that is something lacking, but that is not wrong. Tak salah. So you can put this in your weakness or your improvement of your research. You can highlight the data is inconsistent, and you can highlight if the data was consistent, mungkin your research will be different, outcome will be different. Tetapi untuk mengatakan data awak silap, pergi cari buat data lain, no, it's impossible. it's wrong. Okay? The data is inconsistent, betul, it is a fact, tetapi you cannot say it's wrong, totally wrong, and you cannot ask the student or researcher to go and get back new data. So data is inconsistent, terima seadanya, but you work on that. And then you highlight balik, data is inconsistent. And then you kata, oh, maybe because of the data consistent, that's why I got this result. It's possible. Okay. Measurement of dispersion. Range is the smallest, the simplest measure of dispersion and obtained by taking the difference between largest value and the smallest value. Okay. Okay. So, example, area A has land size of 3,000, B 4,900, and so on, so on, so on. Okay, so the range is largest to smallest 7,000. Thus, the total areas for the four are spread over a range of 7,000. Okay, itu saja outcome. Itu saja you nak tulis. Maybe you want to write. Okay, so you kata the total area yang you study is spread over semuanya, kebanyakannya lebih pada 7,000. So you can say that's range saja. Okay, interquartile is a bit unique. It is a measure of variability based on dividing a data set into quartiles. Okay, contohnya di sini. This is the number. Okay, so what does this number show? This number can tell you, let's say you pergi surau, you tengok ada beberapa orang tua, you tengok umur diorang, and the numbers. The youngest is 62 and the oldest is 81. So you set the median and you buat quartile. Quartile means you buat dalam pembahagian 4 lah. Okay. Maksudnya first quarter, second quarter, third quarter, fourth quarter. Dalam satu quarter tu you get the same number of people. Okay. So the values that divide each part are called first, second, and third quarters, and they are denoted as Q1, Q2, Q3. Okay. So you have this. Okay, now still tak faham. Betul, saya pun dulu tak faham kenapa kita nak buat quartile ni. So what do they do is companies use this data. Some companies use quartiles to benchmark other companies. Example, the median company salary for a given position is set as the first quartile. Okay, as the first quartile of the top 20 companies. Okay, meaning, so in this study they study all the companies and then they buat quarterly, Q1, median, and Q3, and then they find out that this is the salary given. Walaupun tak sama, tetapi berada dalam Q1 ini. Okay, so they can say that walaupun salary yang engineer di sini, gaji engineer di company A tidak sama dengan gaji engineer di company B, but it's all in the same Q1. Okay, all dalam semua kat sini. Okay, semua kat sini. Alright, so this one we already use, but mostly we use it in companies bila diorang nak buat prediction ke apa. Okay, next we also have measurement of variance. Okay, okay, saya ini ya. Okay, so kita dah buat central tendency, variance. Okay, now we want to do variance pula. Okay, variance. Consider the following data sets. Company A ada nilai umur, these are the umur dia. Ada yang 47, 38, so on. Nah, the mean age of workers is the same, 40 tahun. Untuk kedua-dua company ini, setelah tambah tolak, we find out that the mean is sama. By knowing the mean age, it can be deducted that the workers' age distribution is the same. Okay, so daripada sini mungkin kita boleh katakan age distribution dia sama, lebih kurang lah. However, the variation of the workers is very different from each company. Berbeza sungguh. Walaupun purata tu sama, tetapi dia punya variation tu, variasi tu berbeza. Variation tu, it's so much difference. Kalau you tengok company B ni, ada yang sangat tua, lepas tu dia ada benda-benda. Okay, so company B has much larger variation than the ages of company A. Okay, so you want to show there is an age, there's a variation of the age. Okay, CTX, this is another example. CTX, median and mean is 25,000. Meaning apa 25,000? Family income per year. So dalam bandar X, median and mean bersamaan dengan 25,000. So 25,000 itu ialah family income per year. So a zero variation. Every family has an income of 25,000. Means setiap family yang diorang study, dia punya family income setahun ialah 25,000. 25,000, 25,000. Okay, done. Mana yang lain pula? Sama juga, kebetulan sama juga, tetapi they find out that 95% have incomes 12,000 and 5% is 300,000. Okay, walaupun kedua-dua ini dia punya family income dia sama, purata dia sama, tetapi variation mereka berbeza. CTX has perfect variation, equality. That means sama je. Semua orang di situ sama je. Tetapi in CTY ni dia ada inequality. Okay, inequality. Ini ada yang sangat kaya, ada yang sangat miskin. Contohnya kalau you study Jakarta lah, kalau you pergi Indo kan, yang kaya itu sangat kaya, dan yang miskin itu terlampau miskin. Tapi bila dikumpulkan, you get the same mean. Okay, that's all you're saying lah. You kumpulkan semua, sebab ada yang dapat, ada yang middle class, ada yang up, ada yang down, so you campur tolak, mean dia sama. Tetapi when you actually look at the data, you find out that 95% is like this and another 5% is like this. Okay, so mungkin juga kalau you compare Jakarta dengan Bangkok, Jakarta, maybe you compare Bangkok dan Jakarta, you kata, sama je rupanya. Rupanya people in Bangkok family income sama dengan people in Jakarta. Oh, sama je rupanya. Oh, okay. But actually when you go in the deeper, you find that rupanya berbeza. Sebab dia punya variation tu berbeza. Okay? The variation is so much bigger. So that's why we look at dispersion. Dispersion comes up. We want to find out what is the variance. Apakah yang how much it changes. Okay, how much it changes. Next, we also look at standard deviation. Okay, standard deviation means bermaksud it is based on the mean purata and gives an average distance between all the spot and the mean. Okay, meaning to say, apakah yang dimaksudkan dengan standard deviation is daripada purata, okay, daripada purata average distance. That means daripada nombor tersebut dengan purata, apakah dia punya perbezaan itu. Okay, daripada nombor umur, daripada umur si dia tu, okay, dengan purata umur, apakah perbezaan umur itu, that's when we get the standard deviation. Itu maksud dia. Okay, so dalam study ini, mereka ambil, they take the parents' age of class. So dalam kelas A, umur parent mungkin 30, 40, 50, 30, 39 and so on so forth. And then dia orang kira-kira dapatkan mean tu, tolak balik dengan umur parents tersebut, so you get the average distance. Contohnya umur saya 40. Average umur dalam department saya katakan maybe average dia ialah 50. Okay, so the average distance is 40 tolak 50 dapat 10. Okay, so this is the average distance. Nampak ni? Parents in class B are very similar of age. Sebabnya, nampak tu? 0.812. Maksud dia, semua orang lebih kurang sebaya. So secara logiknya, if you look at this, let's say dalam jabatan awak ada 10 orang, okay, katakan 10 orang, and then semua orang umur 40, okay, so mean pun 40, okay, so 40 tolak balik dengan umur seorang tu 40, dia dapat kosong lah. So the average distance is 0, so meaning everyone is almost the same age. Okay, so from here we can say that class B everyone is almost sebaya, and class C everyone is different sebab dia punya variance standard deviation is very high, 6, meaning ada yang tua, ada yang muda, ada tengah-tengah. Okay, ada yang sangat tua, ada yang sangat muda. So that is what you mean by standard deviation. Okay, can you get this example? Saya cari example yang paling senang untuk awak. Don't worry, because we are not statistician. Kita bukannya daripada background numbers. So so I got you simple examples lah, simple ni. Okay, right. So now, sebelum kita berlompat kepada categorical, so now, okay, sebelum kita berlompat kepada categorical, so sekarang dalam bayangkan you dah buat research and you dah buat descriptive analysis, you dah buat mean, mode, median semua, dah buat dah. So now, hasil daripada ini, you want to find out what is the correlation pula. The correlation. The correlation ni apa pula? Okay. So now, kalau kita balik daripada sini, we find out that ini umur parents. Okay. So maybe there is a correlation between the age, parents' age dengan pencapaian kelas. Okay, maybe there is. So hasil daripada data-data ini kita nak buat correlation. We want to find out what is going to happen. What is this all about? So ada dua cara. Satu kita pakai Pearson correlation, atau satu lagi kita pakai Spearman rank order. Okay. Both of these are different because both of these uses different types of data. Okay, ada pakai ordinal, ada pakai ranking. This one we can find out lah. So what do we want to find out in our correlation? Kita nak tahu what is the strength of the variable. Okay, adakah dia semakin naik? The more we exercise, the more we lose weight. So that is the correlation. So we want to find out how much of we naik, berapa banyak yang naik, berapa banyak yang akan naik. So we want to find out. Or is there satu lagi we want to find out, is it a positive correlation? Positive means adakah dia akan naik sama, tinggi, rendah, ataupun terbalik? Is it a negative correlation? Naik satu, turun satu, naik satu. Okay, so we want to find out. That is what it means by correlation. Okay, so what are the steps? First, we have to generate, we have to generate something which is called the scatter plot. Step 2, we calculate and interpret the correlation based on this guideline. Allahu Akbar. Scatter plot ni apa pula? Scatter plot ni to explore the relationship between two continuous variable, example, age and accuracy. Recommend before calculating correlation, provides the indication whether it's a strong or weak relationship. Macam ni. Okay, contohnya macam ni lah. Let's say kita tengok graf yang warna hijau ni, warna hijau ni, dia naik sama cantik. Losing weight and exercising. Katakan losing weight is yang tinggi tu, losing weight is the losing weight is the X and Y is the exercising. Okay, so losing weight ialah X and Y ialah exercise. Okay, so from here we know that semakin banyak kita exercise, semakin banyak kita akan lose weight. So we say it's a positive correlation. Kalau dia weak correlation, kita tengok yang tengah-tengah ni. Very weak. Semua berterabur. Kalau dia tak ada relationship langsung, nampak tu ujung saya none, tak ada langsung. Kalau dia strong, it can also go the other way around. Nampak ni yang strong ni dia boleh turun pun sama juga dikira. It's also okay. And untuk determine correlation, dia ada satu value which is called the R value. R means correlation lah. Okay. So if there is a positive correlation, dia akan naik. Or dia akan turun, sama je. If it's a weak correlation, okay, numbers dia berterabur, data dia berterabur. Okay, all scattered. If there's no correlation, nothing lah, berterabur kat sini lah, tak ada apa-apa. Okay, so first we do this. We want to find out the correlation dulu. Next, we want to interpret this correlation. We want to find out the coefficient. Okay. Jawapan untuk correlation ialah jawapan positif atau negatif. Adakah ada positive correlation between exercising and losing weight? Yes, ada. So what is the coefficient? So bila saya sebut coefficient, coefficient means what is the number. You say it's positive. But what is positive? How many naik, how many turun? How many naik, how many naik? Kalau saya naik banyak, saya exercise banyak, adakah saya akan lose weight banyak? So, berapa banyak yang saya akan lose weight? We want to find out. So when we say about numbers, we are looking at the coefficient. Coefficient bermaksud dia ada number lah. Kalau correlation, dia ada positive, negative, weak or none. Empat jawapan sahaja yang ada. There is a positive correlation between X and Y. There is a negative correlation between X and Y. There is no correlation between X and Y. There is a weak correlation between X and Y. Okay? Alright. If you are looking at coefficient, coefficient means there is a number. R equals to 0.9, meaning there is a high correlation, the number. R equals to 0.2 or negative 0.2, there is a weak correlation. And R equals to 0, there is no correlation. Okay, yang ini semua we can find out through SPSS lah. So always remember, correlation is either positive or negative. Coefficient bersamaan dengan numbers. So, how many? Berapa banyak yang naik? Yes. So perkataan correlation coefficient selalu digunakan sama. So when we say there is a positive correlation, what is the correlation coefficient? So we say there is a positive correlation between exercising and losing weight, whereby R equals to X. Okay, so that is a correlation. Okay, how do you interpret coefficient? Okay, interpret coefficient, kita ada something which is called the p-value. Apakah maksud p-value? Is the probability that we would have seen our data just by chance if the null hypothesis. Okay, so tak apa. Okay, so what is p-value? P-value bermaksud you buat satu kiraan, and if your p-value kurang daripada 0.05, meaning to say jawapan yang you jumpa ni ialah satu jawapan signifikan dan bukannya jawapan secara kebetulan. Okay, that is what it means by significant value. Okay, that means it's significant. Macam mana tahu significant? Balik pada cerita sampel tadi. Okay, sampel soalan Azrul tadi. So we are looking at if the p-value is less than 0.05, then it's a significant value. So we have said that this sample is a good sample, and sample ini boleh boleh bercerita balik untuk population tadi. Okay, if our p-value is greater than 0.05, then it's not a significant value, meaning our sample tidak boleh bercerita balik kepada population. Apa yang kita jumpa hanyalah kebetulan dan tidak boleh disamakan balik dengan population tadi. Halo kawan-kawan.
Ada.
Ada doktor.
Tiba-tiba aja macam poing.
Itulah, dia satu-satu macam okay.
Dia, you have to understand beberapa term kat sini ya. Correlation, coefficient. Correlation, positive, negative. That's it. Okay. Ingat tu je. Coefficient dia ada numbers dia. Dia ada number dia kat situ. Okay. So number dia menunjukkan how much of this increases and how much of that. Balik kepada anak yang darjah 2 tu, lagi besar tuala, lagi banyak air diserap. That is a coefficient.
Okay.
Sebab dia ada nilai dia kat situ. Ada nilai dia. Besar. How big is besar. And lagi banyak air itu, berapa liter dia akan serap. So that is coefficient. Is it a positive? Yes, it's a positive coefficient. Positive relation. Correlation. So correlation selalu berakhir dengan positif atau negatif. Okay? Weak or no. Itu je. Positive, negatif, no or not. Itulah. Tetapi coefficient dia ada number dekat situ. Dia akan letak number. Okay. And then kenapa kita pakai P value ini? P value itu Azrul tanya soalan, what is the cut-off point? Macam mana saya nak tahu yang population saya ini, sample saya ini bercakap pasal population saya? How do I know that my sample, satu sample saya, walaupun sample saya katakan daripada population saya 1,000 orang, sample saya 600, tetapi macam mana, how do I need to prove that 600 yang jawab survey saya ni boleh disamakan balik dengan population tadi? So that's why we have a P value. Kita akan buat satu calculation untuk mendapatkan P value. Okay, we find out what's the P value. So if the P value is less than 0.05, that means ada signifikan dia. Meaning apa yang kita dapat boleh menjawab balik kepada population tadi. Okay.
Doktor, maknanya P value tu kita kira number of population, lepas tu dia dapat dengan apa yang jawapan yang kita dah dapat, kita bahagikan je lah. Nanti dia akan dapat beta atau 0.05 ke atau macam mana? So P ni kita boleh kira ke atau
yes, kita boleh kira. Kita boleh kira P value itu. So kita akan kira P value itu, dia ada formula dia. Kita akan kira P value itu, and then based on the P value 0.05 tu is the statistical value lah, dia ada threshold lah. So once we find out the P value, the significance value, so P value itu ialah probability that we will have seen our data by chance. Okay, meaning P value itu ada kiraan dia. Bila kita dapat kiraan tu, if we find this number P value ini dalam 600 sampel tadi itu, hasil dia ialah we get a number. If the P value is less than 0.015, then it's significant. Maka 600 responden kita sudah menjawab balik kepada 1,000 orang population kita. So ada formula dia untuk kira P value lah.
Oh, okay dah.
Doktor, yang null hypothesis tu macam mana?
Null hypothesis. Maksud dia bukannya apa yang null lah. That means rupanya tak ada kaitan pun di antara exercise dengan losing weight. There's null hypothesis lah.
Okay, baik doktor.
Sebab when you start your research, you always say there is a hypothesis or ada something di antara losing weight, ada something di antara exercise dengan losing weight. So that is a hypothesis lah. Tapi bila you buat kajian, you kata rupanya null, tak ada pula. So awak jangan risau macam Mimi kalau you jumpa null hypothesis. Null hypothesis, awak dah membuktikan bahawa there is no relationship between two variables. Walaupun pada awalnya you kata exercise and losing weight there is a relationship, tetapi setelah you buat your study, you find out that there is no relationship, so null hypothesis. So itu juga satu research lah. You dah membuktikan bahawa tak ada kaitan di antara exercise dengan losing weight. Okay, frequency table. Yang ini, slide nombor 41 ini bercerita pasal bahagian sini. Okay, so maybe you can note this down. pada slide 22 ni, yang categorical ni is kita cerita pada slide 41. Okay, so you can just note this down. Okay, so terbalik-balik pada slide yang ni dulu. Okay, descriptive. Now we are looking at descriptive statistics for categorical data. So what are the tools you have? You can do okay, measures. With all tools pun boleh lah. Okay. Frequency table. You can do a cross tabulation table. Kalau you ada satu variable, you boleh buat frequency table. Tapi kalau you ada 2-3 variable, you boleh buat cross tabulation table. Okay. Right. So frequency table ni paling senang lah. Is a table that lists items and show the number of times the item occur. Categorical data uses label, names or other description. Okay, so dalam demographic tu, you boleh tulis your area, north, south, east, west, jenis-jenis robot, car maker, Proton, Pro2, these are all categorical lah. Smartphone, Vivo, Apple, Motorola, Samsung, Huawei. Okay, so example. Yang ini saya buat satu study kepada 100 orang smartphone users di Perak. Hasilnya saya jumpa macam ni. Ada orang suka Apple, Samsung, Motorola, Huawei, Vivo, others dan lain-lain. Inilah dia saya punya data. Okay. So daripada data ini saya buat satu frequency table. So this is what I found. Ada 45 people yang pakai Apple, Samsung 28 and Vivo 10 and so on. Semuanya berjumlah 100 orang. So how do you use this in your research? Dalam bahagian demografik ni, you boleh bahagikan lah. Maybe you can say project manager less than 5 years, berapa orang? Project manager more than 5 years, berapa orang? Project manager yang more than 10 years, berapa orang? And so on and so forth. Okay? You just do a frequency table. Very simple. Now we do a cross tabulation table, or what we say is a cross tab table. Example, you make informed decision regarding your research by identifying patterns, trends and the correlation between your study and your study parameters. Soalan dia ialah sales of an electric company based on zone and product. So contohnya di sini ialah ini syarikat Seng Heng. Syarikat Seng Heng di zon utara, yang kuning ni, telah menjual produk A, B, C and D. Okay. So, di utara jumlah produk A yang dijual jelas sebanyak 1704, produk B yang dijual jelas sebanyak 1586, so on so forth. So, jumlah production utara sahaja ialah 7,000. Jumlah di South ialah sebanyak 6,000. So jumlah Seng Heng, jualan Seng Heng untuk tahun itu daripada North, East, South, West ialah sebanyak 29,000. Okay. So so how many variables do you have here? You have 2 variables kat sini. One is the zone and one is the product. Okay. So how can you make this work in your research? You can highlight, for example, contohnya macam you bahagikan your study based on zone. Zone Trono, zone Sri Iskandar, zone Motor and so on and so forth. So daripada zone ini, you want to find how many of age 1 hingga 10 tahun, 11 hingga 20 and so on and so forth. So you want to find out. And then you can find out the total number of kids. So this is what we say as cross tabulation. Okay, cross tabulation ni biasanya hanya untuk reporting sahaja. Okay, we want to find the reporting only. Because ini semua dalam cross tabulation ni masih dalam kategori descriptive analysis. It's still under descriptive analysis. Okay, so kalau kita tengok yang okay, if we look here, untuk numerical data, setelah you dapat mean, median, and mode, and you get the variance, untuk you buat inferential, you use correlation, kan? Dia pakai correlation. Untuk categorical data, setelah you dapat semua ni, you dapat frequency table, cross distribution, you can also do not correlation, but you can do another test to determine correlation, which is called the Z test, zebra. So the zebra test will determine what is the correlation pula. Apakah correlation di antara produk tadi, zone dengan produk. Okay, macam example yang last tadi, we are talking about this one here, the zone and the product. Okay, so maybe you say there is something between north and product A. Mungkin banyak produk A itu jual north. There's a correlation. Okay, so you want to find out if there's a correlation. Okay, you tak boleh buat experiment, you kena buat satu test which is called the Z test. Okay, so that one I won't go into lah. That was a bit too detail. Itu semua a bit too detail kalau nak cerita sekarang. Cerita dalam 945 ni memang tak boleh lah cerita-cerita benda itu. Okay, so today is a bit short class sebab saya merasakan awak semua di sana dah terbarai di sana. So I won't continue more. I'll just go to the last slide. Okay, so what is our take home for today? Descriptive statistics describe the characteristics of your sample. Check your variable for any violation and assumption. Okay, what is the violation? Violation meaning you salah ambil. Contohnya you nak ambil categorical, you ambil benda lain. You nak ambil numerical, you ambil benda lain. Okay, that is what it means by violation. You dah salah kat situ dah. Okay, another salah is sample and population. It's also very important juga. You have to determine the right sample, the right population. Okay, kadang-kadang sample betul but population salah. Okay, it can also happen. Okay, so untuk this lecture, the most important slide is this one here. Selain daripada yang atas-atas tu, this one here. Okay, alright. So if you can print out this slide and simpan atas meja, would be very good. So untuk awak buat your descriptive analysis, this is how you should do it. This is how you kena buat lah. Okay, kena buat. Ini untuk descriptive sahaja. This is only for descriptive sahaja. Okay. Alright. Any questions before we end our class today? Kita habiskan awal hari ini.
Doktor, saya nak tanya, macam correlation tadi, maksudnya dia adalah relationship in between dependent variables dengan independent variables kan?
Correct. Yes.
Okay, yang saya confuse sikit yang masa dekat Z, apa tadi? Yang Z equation yang doktor cakap tu, yang itu saya macam confuse sikit bila kita, adakah yang tu kita mencari correlation in between independent variables?
Which one tadi?
Yang masa kita buat frequency table dengan cross tabulation tu kan?
Okay.
Dan kita nak check dia punya correlation in between
Yeah. This one here.
North dengan apa brand A tadi tu.
Yes.
So maksudnya yang tu kita cari the correlation in between independent variables lah.
Yes.
Okay.
So we want to find out what is the correlation between zone and product.
Okay.
So we want to find out. So since dua-dua ni daripada categorical, so maka we cannot use the same test as macam kita buat untuk numerical. So kita kena buat test lain. So test lain tu nama dia zebra test untuk determine what is the dia punya hasil, dia punya outcome dia sama tetapi cara test itu berbeza. Untuk numerical untuk buat correlation, we use the Pearson correlation test. Untuk categorical, we use the Z test. Okay.
Thank you, Doctor.
Okay. Okay, so I will leave you here. Okay, I have uploaded these notes dalam your UFuture. You can get it there. Make sure you sign your attendance there. And insyaAllah habis ni saya akan upload video ini on my YouTube. Okay, link tu nanti saya akan letak sekali link tu dalam UFuture lah. So you can just click on that as well. Okay, alright. You have any more questions before we end our class for tonight?
Doktor, kalau yang critical success factor tu dia macam mana pula?
Critical success factor. If it's a number, then you're looking, okay, kalau dia success factor, if it's a number, it's always numerical lah, senang cerita lah. Kalau dia yes, no, maybe dia ada macam yes, no, dia ada in between semua, then you're looking at categorical data lah. Tetapi dalam satu survey, you can have numerical and categorical, tak masalah. Depends apa yang you nak study. Sebab macam you cakap tadi, descriptive analysis ni, dia dia bahagian depan tu, yang apa yang you cakap tadi, pasal demografik saja. Demografik saja. Cuma yang correlation tu dah terlebih lah. Once you dah buat demografi, you dah buat your descriptive, now you do your correlation semua lah. So slide ni is very important. This slide is very important. You kena ingat numerical. So these are the things you do. Selepas you buat numerical, you want to do your correlation. Tapi ada lah, bukan yang saya kata senang je correlation sampai kat situ. Ada banyak lagi. Dia ada step-step lagi. Dia ada, you kena buat validity test, you kena buat perombak alpha dan segala semua. Dia ada test dia. Okay. But that is what we are heading for lah. Kita nak buat correlation lah. Okay. So secara summary-nya, untuk categorical dan numerical, dua-dua boleh buat correlation. Cuma how we do it is totally different. For numerical, we use the Pearson correlation test. Okay. Untuk categorical data, kita menggunakan teknik zebra test. Kedua-dua teknik ini akan menghasilkan correlation juga. Tetapi berbeza teknik ini. Tapi apa yang dihasilkan is the same. So soalan, adakah you can use Z test itu untuk mencari correlation for numerical? No. Tak boleh. Test Z hanya untuk categorical, Pearson correlation hanya untuk numerical. Kita tidak boleh berpindah-pindah. Okay? Walaupun jawapan dia, walaupun benda yang nak kaji itu sama, tetapi test itu berbeza. Okay? So the most important slide in for today's lecture is in slide number 22. Okay? Alright, are you all okay? Okay? Okay. Alright, thank you so much. I will see you insyaAllah next week. InsyaAllah saya akan cuba buat satu assignment next week lah. Assignment ni jangan risau, tak susah. Saya akan cari soalan-soalan yang killer sikit lah. Apalah, very simple one lah. Very simple one. Okay, alright, so thank you very much for attending my class today, and insyaAllah I will see you next week. So if you have any questions ke apa-apa, you can just ask me anytime, and you can message me ke apa-apa anytime anyway. Okay, alright, so thank you so much.